Welcome back to the workshop. We want to continue taking a look at the third section of the appendix, and here we're going to consider an example of a direct proof. We'll need a couple of details about integers as we work through this proof, but what we'll do is we'll take a look at the theorem or the statement that we want to prove, and then reflect and say, okay, well, what additional information do we need in order to be successful at writing this proof? So let's take a look at our notes. So what we want to consider is let x be an integer, and we want to prove that if x is odd, then x plus 1 is even. And of course, you might think to yourself, well, that's obvious. 4 is even, or sorry, 5 is odd, so when we add 1, we get 6, and that's even. How would we prove this? That's just obvious, isn't it? Well, yeah, it's perfectly fine to think that, because I totally agree. It does seem obvious. But what we should recognize is that we should be able to prove everything. We should be able to prove that this is true. So again, let me remind us that when we're proving an implication, we want to prove the implication is true. So we're only looking at these three scenarios where the implication is true. So we're not worried about this one. The implication is always true when the premise is false. And so essentially what we want to consider is if x is actually odd, right? When we actually have that the premise is true or the hypothesis is true. So when x is actually odd, can we show that x plus 1 is even? If we can, yay. If we cannot, we have a problem, right? We know it, we believe it to be true. Let's prove it to be true. So let's take a look at this. In order for us to be able to demonstrate that a number is odd or is even, we need to know what the definition is, or how we can write each number. So what we use is we use the fact that n is even if and only if m can be written as 2 times some number where that number is an integer. Right? Z is the set of integers. So m is even if and only if m can be written as 2k for some k belonging to the integers. All right. So we can also say that m is odd if and only if m can be written as 2k plus 1 for some integer k. So we can already see that this is almost obvious. To go from an even to an odd, I just have to add 1. That makes sense. Okay, but here we're going from an odd to an even. So we want to show that if x is odd, then when we add 1, we get an even number. And we can do that by recognizing the form in which we can write even and odd numbers. So if m is even, then it can be written this way. Similarly, if it can be written this way, then it is even, because that's what the if and only if statement is. It is the implication forwards and the implication backwards. If m is even, then it can be written this way. If it can be written this way, then m is even. So we want to utilize this idea. So of course we begin by indicating the beginning of our proof by writing proof. I usually underline it. You probably don't really need to, but proof. And then we indent from here. So we're working indented. I'm going to add a little kind of comment here by just saying we're indenting. So let's see, proof. We want to let x be an integer. That's one of the assumptions of the problem, right? It's right here, let x be an integer. We need that. That is crucial. That is very important. If we don't have that x as an integer, then x really may not even be odd. So we have to start with x being an integer. So let x be an integer, and then we begin with our assumptions. So our hypothesis is what we assume. So let x be an integer, and then assume x is odd, right? So we have assumed the premise, or we have assumed the hypothesis. What we've done here is we assumed P. P is X is odd. So we assume that X is odd. Excellent. Once we know that X is odd, we use the definition, right? We can consider this a definition of how we can write or what an odd number looks like. Of course, let's point to odd instead of even, but right, that's an odd number. So since X is odd, we have that X can be written as 2k plus 1 for some integer k. It's important that k is an integer. So when you say X is equal to 2k plus 1, yes, you have to point out that k is an integer. That's a very important thing. If k were not an integer, say, let's say k were 2.5. If k were 2.5, not an integer, 2 times 2.5 is 5. 5 plus 1 is 6, right? Is 6 odd? No, right? So the whole thing falls apart if k is not an integer. So X is odd means that we can write it as 2k plus 1, where k is an integer. Has to be an integer. Very important detail that we have to include. But once we have that, we can go ahead and add 1 to both sides. X plus 1 is equal to 2k plus 1 plus 1. Of course, we can combine like terms then. 2k plus 2, right? I can add the ones together. What good does that do us? Well, if I want to show that something is even, right? I want to show that q is true. I want to show that x plus 1 is in fact even. If I want to do that, I need to show that x plus 1 can, what? Be written as 2 times something. 2 times something, okay? So if I want to show that x plus 1 can be written as 2 times something, I've written out what x plus 1 is. It is 2k plus 1 plus 1. I've combined like terms, and I recognize here that I can pull a common factor of 2 out, and I have k plus 1. Now, this tells us that x plus 1 is even as long as k plus 1 is in fact an integer. And is it? Well, yes, an integer plus an integer is an integer. So we do have that. So since k plus 1 is an integer, again, it is very important that k plus 1 is an integer. If k plus 1 were, right, if k were that 2.5 we said earlier, then k plus 1 would be 3.5, and 2 times 3.5 would be 7. Is 7 an even number? No. Okay, so you have to recognize that. We need to recognize that it is important that k plus 1 is an integer. Excellent. So since k plus 1 is an integer, x plus 1 is even, because x plus 1 is written as 2 times an integer. Excellent. Therefore, so we started with, let's see here, we started with, add a couple of comments here, right? This is assume P, where this is P. And this is Q. So we assumed that P is true, and then we made some manipulations. And from those manipulations, we found that Q is true, right? X plus 1 is even. Once we have that, we just need to go ahead and conclude that the implication is true. That is, we simply say, therefore, if X is odd, then X plus 1 is even. We simply state the entire implication. Therefore, this, okay, is true. And we indicate the end of our proof with a square. That's it. So we have showed that when we have an odd number and we add 1 to it, the result is even. That's it. That's all that we've shown. Okay, the red line is just saying that we're indenting there, and the green comments you don't need to include. Okay, so all that I'm looking for is what's written in blue. That is the proof. Excellent. That's all that I wanted to share for this video. So I'll see you guys back in the workshop in just a little while for another example.